So we covered drag before in a couple problems, just the ones there recently, for singular moving bodies. Here is a more formalized video about drag. So it's a naturally occurring resistive force just like friction, and it almost acts as a bit of air friction. Drag cars sort of come from a different meaning of drag, however, they do indeed produce a lot of drag. However, engineers of drag cars try to minimize it, which is why you see these long snouts. So the air kind of rushes up and kind of flicks off forward, so it produces less resistive forces. So in general, with falling objects, the drag force is proportional to the product of the mass and some power of the velocity. So we can write it mathematically as F sub d is proportional to mv to the power of n, which implies that Fd is some kVm to the n newtons of drag, where k is a constant. So in these lectures, we'll only discuss one-dimensional falling objects, because projectiles with drag can be slightly complex. So I probably will make some videos about projectiles with drag. It essentially just changes the Sx equals uxt into including the drag force. However, for these lectures, we're only going to be discussing one-dimensional moving objects in free fall. Other times it'll just be a naturally occurring resistive force.